Alrighty, good morning, ladies and gentlemen. Happy Tuesday. I'm redoing this video because the first one had a very bad sound quality, but plan for the day is that we're doing human evolution. Couple of things I want to talk about is mainly that I want to talk about the theories surrounding human evolution, kind of what we have as a picture of it, and to kind of debunk a few processes and just talk about what we mean when we're talking about human evolution. So I'm going to start by debunking sort of a thought that we kind of all have. And right here we have sort of the evolution of man. If you type it in Google, you'll find a whole bunch of different images. But what this seems to be suggesting is that we have this sort of progression. And while that is somewhat true, what we've learned about evolution is that this is really not the whole picture. This is not the story. So you'll find that there's a lot of contention around this. So I kind of want to start by saying, like, this isn't technically what we're seeing in base sense. A lot of the things you'll see is, like, if we have, like, say, like chimpanzees or chimps here, humans here. Chimpanzees have not evolved into humans because we still have chimpanzees. There are two different species. So we're going to get into that a little bit, but I want you to kind of take this image and put it aside for now. It's not quite what we think when we see this, and I'll talk a little bit more about this later. So what I want to go into next is to just kind of give us a phylogenetic tree of different primates. So we can see here, about 50 million years ago, we have primate ancestors, and we split up into our closest relatives. So humans are on the far right-hand side over here, and I'll make a little divider here. We have our closest relatives in our primate family that are still existing, which is the chimpanzees. And at the top, there are three categories that we've linked them into. So there's prosimians at the far left. These are things like lemurs, lorises, tarsiers. Then we get into an organizational group called arthropods. So these involve monkeys, gibbons, orangutans, gorillas, chimpanzees, and humans. And then from there, we have something called hominoids, which also includes humans, but it is a subset of arthropods. So these are kind of our clades. So our arthropod clade would start back here and include everything here. Hominoids includes gibbons, so it would go back this far and include everything here. And there's a third category, and this is the one that we're going to be interested in, and we call them hominins. Now, we are the only surviving hominin species. We'll talk about kind of the main features, and you'll see that why we've made this distinction in a few moments. So I'm gonna go over here, and we're gonna compare the main physiological differences between a hominin and a hominoid. So here I have, on the left, I have a human skeleton, and I have a gorilla over here. Now there's four main differences that I'll be talking about. There's obviously more than that, but when we're talking about physiological differences, you'll see that this lends itself to two major features of the hominin genus. So, number one, I'll talk about spine shape. So, spine shape refers to what shape the spine of the organism takes if we look at it from either a side view, generally from a side view. So if I look at the human, the spine follows this sort of curve, whereas a gorilla, depending on how it is standing, is sort of this shape. So for humans, or I'll say hominin, we have what's called an S-shape spine. And for hominoid, we have a C-shaped spine. Doesn't really look like a C in this image, but you can see that it kind of curves down both of the top and the bottom of the body, and it kind of has this long straight line. So kind of like a C. Kind of like how ours is an S, but only kind of. Second is where is the spinal curve location. Sorry, not spinal curve location, spinal cord location. For humans, or I'll say hominin again, we have the bottom of the skull. For hominoid, we have the back of the skull. Now for us, what's important, I'll switch colors here. For us, our spinal cord goes down out the bottom of the skull, whereas if you look where the spine connects here, it more comes out of the back of the skull. So there's a difference in how the skull connects to the spine. Number 3, it's going to seem weird, but limbs. So hominins have longer hind limbs, and when I say hind limbs, I mean legs. So hands don't touch the ground. For hominoid, we have longer forelimbs. Scroll over. Now, when I'm talking about this, we can definitely touch our hands to the ground, but when we think about locomotion, how we move, humans and hominins' arms generally didn't touch the ground. And as a result of this, their forelimbs were a little bit shorter. Whereas in this image, you can see gorillas use all 4 of their limbs to move around, and as such, if we just look at the length of the limbs, we can see clearly that the front limbs are much, much, much longer. And then lastly, we have the pelvis. When we're talking about human evolution especially, pelvis size and shape is extremely important for a specific thing that we'll talk about. So again, hominin, we have a bowl-shaped, and it's hard to see from this angle, but our pelvis is right here, so you can see it's kind of this bowl shape. Hominoids, on the other hand, have sort of a long and narrow shape. So I'll erase that. So you can see the pelvis is sort of this region here. It's very differently shaped. Now, there's 2 kind of key features here. So these 3 here all lend themselves to one thing. They all hint at the same idea. And we can imagine the shape of our spine, the S shape, puts us in a more upright position. If our spine is in a more upright position, we want the spinal cord to come out of the bottom of our skull so we can look forward. Whereas with a gorilla, if it's more slanted towards the ground, you're going to want the spinal cord coming out of the back of the skull. And then the limb locations or the limb sizes, really tells about how this creature moved around. So what we find the main difference is that these 3 lead to is something called bipedalism. So 2 legs, and then quadrupedalism, 4 legs. And this is how we move around. So Most hominoids move around using 4 limbs. They can use 2, but it's awkward. Whereas most hominins are moving around on 2 legs. The other thing about the hind limbs I want to mention is that they are below the pelvis, and then they're kind of pointed outwards. If you've ever seen a chimpanzee walk, you'll notice it kind of has to waddle because its hind limbs are coming out at not directly below it. Now, number 4, this leads directly to one of the other features. You can see here the shape of the pelvis, and then here it's a lot more sort of oblong and narrow. Now, pelvis is important for one major reason, and that is brain size, because if you're a developing child inside of the parent or the mother, you have to be birthed through this hole. And the size of the hole, because it's bone, can't change, so it limits how big a child's skull can be. Now, our brains are quite a bit larger per our body size than, say, a gorilla's, so this is one of the other key features that we find. And you'll actually see in one of the cladograms I have that brain size is one of the ways that we measure this sort of lineage. So, moving on, here's our image of different hominins and Homo sapiens species moving around. We think that they came from Africa, and we find different fossil records all over Europe and Asia, and it happened several times. So this is in your textbook. I'm not going to go over that one too much. What I want to show you is that there's 2 different pictures. Now, one of the things, we're not always super confident. You'll notice here I've got a time frame, and here I've got a time frame, and they use very different values. Some of them say 6 million years ago, this one says close to 8. Either way, we're dealing a lot with fossil records here, so we don't always have a complete view. As we find more, we refine it, but this has a lot of good information for us. Key things that we need to know: chimpanzees are over on the far left and at the top. So we split off from chimpanzees and bonobos anywhere between 6 million years ago and 8 million years ago. So everything after here, so if I kind of draw this vertical line, horizontal line, here are hominins, and here we have our hominins. Now, other thing to keep in mind, we are the only surviving species of this cladogram. Every other type is extinct. Now, first thing that comes forward is this adaptations for walking bipedally. The other thing that we focus on is on skull shape, and these are based on fossil records that we find. There's going to be a couple that I'm going to talk about, but we're going to be coming back to this, but I just wanted you to take a look at how the skull shape changes as we go down. If we have chimpanzees here and we have human skulls here, you can see how it changes over time to sort of transition from this ape-like appearance to a more human-like appearance. And then we can see that if we look at our closest relative, we find Homo neanderthalis, where they have a very similar appearance in a skull. It's different, of course, but it is similar. And we can see after a certain point, if I go back to about here, there is a visible difference in skull shape, where on the top it appears much more ape-like, and on the bottom it appears much more human-like. And we can kind of see the similar features here, how we kind of move from a human skull to a more chimpanzee-like skull. So one of the things that I want to talk about here is that fossils are comparable to humans. They form a new genus. So one of the things you'll find is that there's 2 major ones. There's the genus Australopithecus and the genus Homo. So when we talk about Homo sapiens, Homo erectus, Homo habilis, Homo neanderthalis, these are creatures with very similar human physiologies. Whereas if I go above it, I start to find Australopithecus, so different versions. And they clearly look different. An example of this, if I go over here, we deal with this different genus as sort of a transitional species. So what I mean by transitional species, we've talked about it once before. This is an in-between species. So it is kind of like one, kind of like another. And in this case, this is our transitional species between chimpanzees and humans. So both of these skeletons are from the Australopithecus afarensis. So to remind you, we have our genus and we have our species. And some of you may be familiar, we found a skeleton or a fossil of one of these organisms called Lucy. And believe it or not, this is Lucy here. So we don't actually have a lot of information. We don't have a nearly complete skeleton. But from this, scientists have been able to build a couple of features, mainly because they have some bones from the foot, they've got some bones from the pelvis, and they've got some bones from the skull, which are key for helping us out. Recently, I think in 2015, we found another skeleton of a child from this, and we called it the Dakika baby. Now, this creature shared a lot of features in common with apes and chimpanzees, as shown by a reconstructed photo here, but it also shares a lot of features with humans, which is why we refer to it as a transitional species. So for the Dakika baby, we found a little bit more information. We had a much more complete skull, and we had a part of the ankle and foot. Now, a couple of other images that we have. What we rely on a lot for identifying this is skulls, pelvis, and feet. Reason being, skull gives a good idea of brain size and what it may have eaten. Pelvis also gives us good hints at how it moved and brain size. And then foot, especially ankle, would show how it walked around. So if I zoom in here, what I want to draw attention to is a chimpanzee's foot, Lucy's foot, and a modern human's foot. So you can see a chimpanzee's foot, how it's splayed out is much more prehensile. It almost has like thumbs, which help it grab onto things. This would be more for climbing through trees, whereas we found with Lucy and other skeletons of the same genus that it has a much more bipedal foot. It actually has much more in common with us. But most of its other features have a lot in common with chimpanzees. So this is what we mean by transitional species, where it has a little bit of both built into it. So, other part that I'll bring up, we have some fossil records of different creatures. If we notice gorilla is here, chimpanzee is here, so or pan, I'll just say chimp up top. And then we have humans here. Now there's two kind of possible stories here. And they have it by color. So we have terrestrial bipedalism, terrestrial quadrupedalism. So bipedal means that you walk on 2 feet, quadrupedal means you walk on 4, and terrestrial means you're on land. The other one is what's called arboreal, and arboreal stands for trees. So you're moving through the trees with 4 limbs. Now there's 2 ideas. We don't have a complete image because we don't have complete fossil records, but we think at some point, if we go far enough back, all the primates were designed to be, or all primates had arboreal capabilities. They climbed in trees. We know that gorillas and chimpanzees can also move around on the ground, but we're not sure of when this change happened. So mainly our two changes are either it happened separately, where gorillas and chimpanzees evolved out of the trees, and then later on humans and our relatives evolved to walk on land, but otherwise they stayed in the trees this whole time, or we stayed in the trees up until this point. We started moving on the ground from here, and chimpanzees and gorillas stayed on the ground but kept using forelimbs, and then at a much closer date we started walking upright. Now we don't know, but these are two of the theories that exist out there. Alright, well, one of the last things I want to talk about is our closest relative. We have Homo neanderthalis and Homo sapiens. So these are our Neanderthals and modern humans. So, quick feature of Neanderthals, they lived about 200,000 years ago up until about 28,000 to 24,000 years ago. This is when they went extinct. Now, a couple of key features. They generally had larger skulls than us. They were shorter, but much broader. And a few things that we know about them as a species: we know that they knew how to use fire, we know that they knew how to use stone tools, and that they had complex social structures up and including the fact that they had ritual burials. You can see that there are differences though. So brain case shape, you can see ours has a much rounder appearance, whereas theirs was much longer. Forehead ridges had a very different shape. How the nose came out, cheekbones, chin. The chin was a little bit more recessed here, whereas ours were a little bit more pushed forward. And so I want to put this forward as just a comparison. The reason why is because humans and Neanderthals actually coexisted at the same time. We were both alive at the same time. What we think happened to the Neanderthals, because they were broader and shorter, they had a different food source. We generally thought that they were stronger than us, and that they were meant for hunting big game like the woolly mammoth and other large animals that were alive at the time. Whereas modern humans, or even early humans, had a much more bipedal nature, where we would chase and run down creatures for food. Because we were smaller and a little bit more slim, it meant that we didn't need quite as much energy sources, or as much high energy sources, as Neanderthals did. So as these large animals went extinct, so did Neanderthals. So modern humans, they were around about 100,000 years ago. So you can see we've had about 80,000 or so, or 70 to 80,000 years of coexistence with Neanderthals. And in fact, we actually share some genomes, which means that at some point, Neanderthals and humans were reproducing with one another. All right, last thing I really want to talk about, we're getting close to the 24-minute mark, so I want to wrap this up. I want to talk about this idea of relatives and ancestors. So this is going back to that very beginning part that I was talking about here. When we think about human evolution, a lot of things we'll talk about is sort of this progression from one to another. But I want to point out that basically all fossils of hominins we find are relatives. So what I mean by that is, when we talk about relatives in terms of genetic lineage, we are talking about at some point we have branched off. There's kind of two ways that we can think about evolution. A lot of people think of it sort of like a tree where we have common ancestor, and then we go up, and then very sort of at the end we have chimps, humans, and everything sort of evolved together up until this point. And this is not what we find. What we instead find is that it's more like a bush, where there's a lot of branches. There's some trunks that are bigger, but generally speaking, it's a lot wider than we think of. And when I'm talking about relatives, I am referring to all of these sort of side-by-side organisms. Some of them are not alive anymore, some of them went extinct long ago, but rather than it being one complete trunk where one creature evolves into another, one creature evolves into another, one creature evolves into another, and then eventually they divide, we think that this dividing has happened lots. And it makes sense when we talk about evolution as being responding to different environments. I want to bring back this sort of image of two paths in the woods. You have one niche here, and then another. If we think about speciation, this is how it works. We have two different options. There's a divergent path. Some creatures evolve this way, some creatures evolve this way, and then we end up with two species over time, and then whatever happens after then will be separate. So this is where I'm saying I want to kind of discourage this thought of like us turning into different creatures over the span of time. A lot of what we find are relatives, and that we come from a common ancestor, but a lot of our images and a lot of our information is incomplete in the sense that we find a lot of fossil records of these relatives more so than we find common ancestors. Anyways, that's all I have for you today. Hopefully you found this interesting and informative. It's definitely something that a lot of people think about when they think of evolution, is like where do we come from? So hopefully you gain a little bit of information. There's a lot out there. This is something that is widely being talked about even today, because as we find new information, we refine our concepts of how we came to be. Anyways, take care. Hopefully you're all staying safe. Hopefully you're enjoying enjoying June. And as always, stay safe. Take care.